When it comes to diffuse and specular reflection, I'm going to explain these ideas using a diagram which looks something like this. On the left-hand side, we have 100% diffuse behavior. On the right-hand side is 100% of a specular reflection behavior. And this surface is just imaginary for the time being. In the middle, we have this eye, and that might represent the eye that we see things from. Or it kind of looks like a little Illuminati eye, but whatever you want to imagine for that. Now here's the explanation that you've probably heard before. When it comes to diffuse reflection, we have all of these variations in the surface. And as light hits these variations, what ends up happening is that light goes in all direction, and that determines the diffuse behavior. And then on the specular side, the thing which makes it specular reflection has to do with how smooth that medium is. And if it's a smooth medium like this, then we have a clean reflection. However, this is wrong. And as a matter of fact, if you think of it this way, you're going to run into a lot of confusion once you run into the roughness parameter inside of any shader that you're working with. And so this isn't what's actually happening. And if you don't believe me, think about this for a second. If you were to take a plank of wood and polish it so finely that the surface of that plank of wood down to the atomic level was about this smooth, you would still never get pure specular behavior. It would never behave like a mirror, no matter how much you polished that plank of wood. And so because of that, this model, this way of understanding light is incorrect. Instead, it's better to imagine the surfaces at an atomic level. After all, the atoms which make up everything in the world, they're the ones that actually re-emit light as it hits them. And so if we imagine a bunch of atoms, and on the left-hand side, we still have purely diffuse behavior. On the right is still a purely specular behavior. This is a better start to understanding what's going on. Now, as light hits these individual atoms, three things could happen. That light could be reflected through reflection, it can be absorbed, or transmission can occur. And that basically means that the light goes through the medium. So, in this case, we're talking about diffuse and specular reflection. And so we are, in particular, talking about this behavior. How does light reflect off the atoms? Now, notice that we don't actually ever reflect light off of atoms. What actually happens here is that the photons which hit these atoms will excite the atoms. And the atoms, with their electrical charge, will be disturbed. And so try to imagine these atoms sort of vibrating, and the vibration of these atoms is altered, and so the actual atoms try to get back to their normal states, and through that vibration, it sends out more light. And that's basically what reflection does. Light hits it, it excites the atoms re-emit the lights as photons. And so that is what happens when something is reflected. Okay, so with that in mind, this is what's happening when we see diffuse behavior. Light enters into the medium. The medium is a collection of atoms, but these atoms may not be very tightly packed together. And anything that is a diffuse object will have a bit of light that enters into the surface a little bit, and it's going to bounce around all these different atoms. And because of all these different bounces, you'll end up with the light exiting at all sorts of different directions. And so what we can say about this is that what makes a reflection diffuse in its behavior is primarily due to the way that light scatters in the medium. The nature of this scattering depends on the atomic structure, so factors such as how densely packed the atoms are, which relates to IOR, something I'll talk about later, and the electromagnetic properties will influence this behavior. So all that's to say that with diffuse objects, light bounces around a little bit in that object, and because it bounces around and re-emits at all sorts of different angles, that is what we're describing whenever we have diffuse light. Now, something to keep in mind is that in computer graphics, we approximate this. And a very common way of calculating this in computer graphics is through something called Lambertian reflectance. The main idea is that we don't want to think about all these bounces within the medium because that takes a lot of math and a lot of computation to actually think about this. Besides, we have something else called subsurface scattering, which I'll talk about later to deal with situations like that. So instead, what we do is we find a point on the surface and we say, all right, well, let's just make a general thing here that says light goes in all directions. And that is essentially what Lambertian reflectance does. In the real world, however, this is what actually happens. And another thing that I should mention is that with diffuse objects, this scattering doesn't go very far in most objects. It goes far in something that's oftentimes water-based, like skin, and that is what you would call a subsurface object in computer graphics. But for, let's say, a plank of wood, oftentimes the scattering happens at such a small level that we really don't perceive that object as being a subsurface object. But technically speaking, in the real world, all diffuse light behaviors are technically subsurface because of this bouncing effect that happens within the medium. When it comes to diffuse reflection, we don't have any settings on the principled shader, and that's because with the principled shader, it's going to assume that all objects have this diffuse reflection, and unless you state something otherwise, it's just going to take care of what those values ought to be underneath the hood. And so depending on what render engine you're using, sometimes you have access to the diffuse weight, sometimes you don't. In this case, the principled shader, it's going to manage all the proper values under the hood. And if we change some of these other settings, then it will just automatically change to what it needs to be. Now, this might be a little bit confusing at first, but this base color and the albedo multiplier, that doesn't relate to the amount of diffuse reflection. These parameters, albedo in general, that has to deal more with absorption. Because if we change this color, it's also going to change the color of our specular reflections as well. But I'll get more into absorption. That's also related to IOR a little bit in the future. For now, just know that diffuse weight, it's all taken care of. You don't have to worry about it with the principled shader. And in the next video, let's move on to specular reflection.